Good day, everyone. Welcome to Wanies Academy. Today's subject is chemistry, and we'll be looking at hydrocarbon. Let's look at the aim of the lesson and the objective. The aim of the lesson is to help you understand what hydrocarbons are, their main types, and how they are used in our everyday activities. At the end of this lesson, you should be able to define hydrocarbon, identify the main types of hydrocarbon, explain some of their properties and uses. Now let's dive into the lesson. What are hydrocarbons? Hydrocarbons are organic compounds made up of only two elements, which are carbon and hydrogen. They are made up of two elements, which are carbon and hydrogen. So these hydrocarbons are the basic building blocks of many fuels and chemicals we use daily. Most hydrocarbons are obtained from crude oil and natural gas through processes like fractional distillation and cracking. Now, what is fractional distillation? This is the separation technique used to get hydrocarbons from crude oil, while cracking is the breaking down of a larger molecule into smaller ones, in which these smaller molecules are used as hydrocarbons. For example, petrol, natural gas, and even plastics are made from hydrocarbons. Now let's look at the types of hydrocarbons. We have two main types of hydrocarbons, which are the saturated hydrocarbon and the unsaturated hydrocarbon. Saturated hydrocarbons are hydrocarbons with only single bonds. An example is alkane. Alkane is an example of a saturated hydrocarbon. Let's look at examples under alkane. We have the methane, ethane, propane, and so on. So these are examples of alkane. Looking at the formula, the general formula of alkanes and the formulas of each of this, I'm going to show you why each of them is a single bond. We have alkane to be CH4. And if you are to display this, you have C H So this is an example of a saturated hydrocarbon. Each of them have a single bond. This is methane. Let's write that of ethane. We have C, T, So the bond that exists in alkanes is a single bond. This is a single bond between the carbon atom, and also a single bond between the carbon and hydrogen atoms. So alkanes are example of a saturated hydrocarbon. Let's look at unsaturated hydrocarbons. These are hydrocarbons with more than one bond. When we say more than one bond, we're talking about double and triple bond. Examples of hydrocarbons under this category is alkene and alkyne. We have the alkane and alkyne. This is an example of an unsaturated hydrocarbon. Let's give each different examples. Let's write ethene. If we have ethene, and ethane. Okay. If you are to draw if you are to draw the structural formula of ethene, we have ethene is C2, C2H4. While that of ethane is C2, C2H2. So looking at the displayed formula of each of this hydrocarbon, we are left with C, H. This is a double bond. So we have double bond we have double bond in ethene, which is this is the double bond. While that of ethane exhibits a triple bond. If we are to write C2H2, we are left with this is 2 and 3 C H and H. So these two are examples of unsaturated hydrocarbon, alkane and the alkyne series. Example under that is ethene, which is C2H4, and ethane, which is C2H2. These unsaturated hydrocarbons are very reactive and they are useful in making plastics and other chemicals. Let's look at the properties of hydrocarbons. The first on our list is combustion. Hydrogens burn in oxygen to release energy. Now, combustion exists in two places. We have the complete combustion and the incomplete combustion. Complete combustion produces carbon dioxide and water. This is when an alkane or an hydrocarbon burns in a sufficient supply of oxygen. Incomplete combustion is the opposite, which is an hydrocarbon burns in an incomplete or insufficient supply of oxygen. Now, solubility. Hydrocarbons are soluble in water, but they are insoluble in water, but soluble in organic solvents. This is why petrol and water don't mix. They don't mix. Whenever we get water, hydrocarbons are insoluble in water but soluble in organic solvents. The density, most hydrocarbons are less dense than water, so they float. They are less heavy than water, so they float. The boiling point, as the number of carbon atoms increases, the boiling point also rises. That is why methane is a gas, but kerosene with many carbons is a liquid, or your petrol is a liquid. So the higher the carbon atoms, the higher the chain length, the higher the boiling point. The reactivity as well. Alkanes are relatively unreactive, except in burning. If you are to look at the types of hydrocarbon, the alkanes, alkynes, and alkene, alkanes are generally unreactive due to the presence of their single bond, while alkenes and alkynes are very reactive because they have double bond and triple bond. Cracking. Large hydrocarbon molecules can be broken down into smaller and more useful ones. This is how we make petrol from heavy oil fractions, petrol from crude oil. We can't use crude oil, so large molecules are broken down to form a smaller molecule, which is a more useful one. So let's look at the uses of hydrocarbons. We use hydrocarbon in our everyday activities. It is used as fuel in that's for your transportation like petrol, diesel, natural gas, and so on. It is also used as a form of raw materials. Your polythene bag. Alkenes make plastics and also makes your polythene bag. So in industries, hydrocarbons are used in industries to produce consumer products like your detergents, your alcohols, your synthetic rubber, and many others. For construction, hydrocarbon is also useful. Bitumen is used for road construction and roofing. So you can see hydrocarbons are used in our everyday activities. We can't do without chemistry. So we have come to the end of chemistry. We've come to the end of today's class. Kindly hit the subscribe button and follow for more. See you in our next class. Bye.